So we need to find the integral 1 upon x plus 1 into x plus 2. So x plus 1 and x plus 2, they are consecutive, and we know that 1 upon n into n plus 1, we can write 1 by n minus 1 by n plus 1. So we can apply the same logic here. So we can write 1 upon x plus 1 minus 1 upon x plus 2 integral. So we can separate it. Integral 1 upon x plus 1 dx minus integral 1 upon x plus 2 dx, which is equal to log mod of x plus 1, because integration 1 upon ax plus b dx is equal to log mod of ax plus b divided by a. So here the coefficient of x is 1, so you can write log mod of x plus 1 minus log mod of x plus 2 plus integral constant c, or we can also write log mod of x plus 1 divided by x plus 2 plus c, since log a minus log b, we have the property log of a by b with the same base. So that we can go with an option log of x plus 1 by x plus 2 plus c, which is option 4. So we need to find integral minus 1 to plus 1 sine power 5x and cos power 4x dx. And we know that integral minus a to plus a f of x dx is equal to 2 times integral 0 to a f of x dx when f is even function, and which is equal to 0 when f is odd. So let us check whether this function f of x, let f of x is equal to sine power 5x into cos power 4x, whether it is odd or even. For that we need to take f of negative x, which is equal to sine power 5 of negative x into cos power 4 of negative x. And we know that sine of negative theta is equal to minus sine theta, and cos of negative theta is equal to cos theta. So we can write negative sine x whole power 5 into cos x whole power 4, which is equal to negative sine power 5x into cos power 4x, which is equal to minus f of x. Means this function is, we can say, sine power 5x into cos power 4x is odd function. If it is an odd function, so minus a to plus a, that is integral minus 1 to plus 1 sine power 5x cos power 4x dx will be equal to 0. So we can go with an option 4. So we need to find the integral 0 to 2 pi under root of 1 plus sine x by 2. And we know that we can write 1 plus sine x by 2 as 1 plus 2 sine x by 4 into cos x by 4. Since sine theta is equal to 2 sin theta by 2 into cos theta by 2. And here we can also write 1 as sin square x by 4 plus cos square x by 4 plus 2 sin x by 4 into cos x by 4, which is in the form sin x by 4 plus cos x by 4 whole square. Therefore, under the root of 1 plus sin x by 2, we can write it as mod of sin x by 4 plus cos x by 4. And here in the integral, x lies between 0 and 2 pi. So x upon 4 lies between 0 and pi by 2. So in the first quadrant, sin x by 4 and cos x by 4 both are positive. So we can write directly sin x by 4 plus cos x by 4. We can remove the model. Now let us consider the integral 0 to 2 pi under root of 1 plus sin x by 2, which we can write it as sin x by 4 plus cos x by 4 dx. Integration of sin x is minus cos x. So here minus cos x by 4, and coefficient of x is 1 by 4, so you should divide with 1 by 4 here, and again plus integration of cos is sin x by 4, again divided with coefficient of x is 1 by 4 over the limits 0 to 2 pi. So we can write it as minus 4 cos of x by 4 plus 4 sin of x by 4 over the limits 0 to 2 pi, which is equal to negative 4 of, applying the limits, cos 2 pi by 4, that is pi by 2, minus lower limit cos 0, and again plus 4 times sin 2 pi by 4, that is pi by 2, minus sin 0, which is negative 4 times of cos pi by 2 is 0 and cos 0 is 1, and plus 4 times of sin pi by 2 is 1 minus sin 0 is 0. So we can write minus 4 into minus 1, that is plus 4, and plus 4, which is equal to 8. So we can say the answer is 8, which is our option 1. So integration 1 upon x square into x power 4 plus 1 whole power 3 by 4 equals to, so we can write integral dx upon x square times, we can take x power 4 common inside the bracket, so we can add 1 plus 1 by x power 4 the whole to the power of 3 by 4, which is equal to integral dx upon x square into x power 4 whole power 3 by 4 is x power 3, and 1 plus 1 by x power 4 whole to the power of 3 by 4. That is integration dx upon x power 5 times 1 plus 1 by x power 4 whole power 3 by 4. Let us go with the substitution method. Put 1 plus 1 by x power 4 is equal to t, so that we can write differentiating with respect to 2x. So 0 plus minus 4 divided by x power 5 dx is equal to dt. that is 1 by x power 5 dx is equal to minus 1 by 4 dt. So this integral we can write it as minus 1 by 4 dt divided by 1, that is t to the power of 3 by 4. Again using the integral, minus 1 by 4 into integration of t power minus 3 by 4 is t to the power of minus 3 by 4 plus 1 divided by minus 3 by 4 plus 1 plus integral constant c. So minus 1 by 4 into t to the power of, and here 1 by 4, the whole divided by 1 by 4 again. So minus 1 by 4 plus 1 by 4 gets cancelled, plus c, which is equal to minus t to the power of 1 by 4 plus c. So where t is equal to 1 plus 1 by x power 4 whole power 1 by 4 and minus plus c is the answer. Or we can also write it as negative of x power 4 plus 1 upon x power 4 whole power 1 by 4 plus c. So which is our option 4. Let us consider the integral I is equal to 0 to 1 log of 1 upon x minus 1 dx, and we can also simplify 0 to 1 log of 1 minus x upon x dx. Say this is 1. And now by using the King's property, integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So here I is equal to integral 0 to 1 log of 1 minus of 0 plus 1 minus x divided by 0 plus 1 minus x dx, which is equal to 0 to 1 log, and here we can write x divided by 1 minus x dx. See the I. Let us consider this as 2. Now adding 1 and 2, so we get 2i is equal to, so integral 0 to 1, both are having the same limits, we can take directly log of 1 minus x upon x plus log x upon 1 minus x dx. So that we can write 2i is equal to integral 0 to 1 log a plus log b is log ab. So we can write 1 minus x upon x into x upon 1 minus x dx. So log 1 is 0. So 2i is equal to integration of 0 to 1 log 1 dx, which is equal to 0. So I can write integral I is equal to 0. So we can give the option 2. The area bounded by the curve y is equal to sine of x upon 3 and the x-axis, and the line x is equal to 0 and x is equal to 3 pi. Since x lies between 0 and 3 pi, x upon 3 lies between 0 and pi. So sine of x upon 3, in first and second quadrant it is positive, so it lies between 0 and 1. And we can see the graph. So this is the graph, y is equal to sine of x upon 3. And between the lines x is equal to 0. And the line x is equal to 3 pi. And x-axis. So we can see the area formed. So by using integrations, we can find the required area, which is equal to integration 0 to 3 pi sine of x upon 3 dx, which is equal to integration of sine is negative cos of x upon 3, and the coefficient of x is 1 upon 3, so it is divided with 1 upon 3, and over the limits 0 to 3 pi. So we can also write this minus 3 times cos of x by 3 over the limits 0 to 3 pi. Now substituting the limits, upper limit, that is cos of 3 pi divided by 3 minus the lower limit cos of 0 by 3, which is equal to minus 3 times of cos pi, which is negative 1, and here cos 0 is 1, which is minus 3 into minus 2, which is equal to 6 square units. So the area formed bounded by the curve y is equal to sine of x by 3, x-axis, and the line x is equal to 0 and x is equal to 3 pi is 6 square units, which is our option 3. The area of the region bounded by the curve y is equal to x square and the line y is equal to 16. So here is the point 0, 16. So this line is y is equal to 16 and this curve is y is equal to x square, and the area bounded is so which are two symmetrical portions. So by using integrations with respect to y-axis, so we can write required area, which is equal to 2 times integration 0 to from 0 to 16 units, that is 0 to 16 x dy. With respect to y-axis we are doing, so 0 to 16, since y is equal to x square, so x is equal to under root of y, so root of y dy, which is equal to 2 times integration 0 to 16 y to the power of 1 by 2 dy, which is equal to 2 times y to the power of 1 by 2 plus 1 divided by 1 by 2 plus 1 over the limits 0 to 16. So we can write 2 times y to the power of 3 by 2 divided by 3 by 2. So over the limits 0 to 16. So we can write 4 times, or 4 upon 3 we can take separately, and y, that is 16 to the power of 3 by 2 minus 0. So we can write 4 by 3 into 16, we can write 4 square whole to the power of 3 by 2. So that 4 by 3 into 4 cube value. 4 cube is 64, 64 4s are 256, 256 divided by 3 square units. So which is the required area, which is our option 2. So 256 by 3 square units. We need to find the general solution of the differential equation dy by dx plus y into tan x is equal to secant x, which is in the form of dy by dx plus y p of x into y is equal to q of x. So here p of x is equal to tan x and q of x is equal to secant x. So therefore integrating factor if is equal to e to the power integral of p of x, that is tan x dx, which is equal to e to the power log mod of secant x. Since e to the power of log of m is equal to m, so we can write mod secant x. Since we know that e to the power log to the base e x is equal to, we can write x by using this property. So mod of secant x. So therefore general solution y into integrating factor secant x is equal to integration of q of x, that is secant x, into integrating factor is again secant x, that is integration of secant square x dx plus c. So integration of secant square is tan x. So we can write y into secant x is equal to tan x plus c is the general solution, which is our option 1. Given the differential equation d square y by dx square the whole power 2 plus dy by dx whole power 3 plus x power 4 is equal to 0. So in this differential equation, we are using the first order derivative dy by dx and second order derivative, that is d square y by dx square. So the highest order derivative we are using is second. So we can say that order of the differential equation is, which is given as a is equal to 2, and the power of the highest order, that is order of the differential equation, is 2 and the power is 2. So therefore we can say that the degree of the given differential equation, which is given by b, is also 2. Therefore the value of a minus b, that is 2 minus 2, which is equal to 0, which is our option 4. So we need to find the distance of the point minus 3, 4, 5 from YZ plane. We know that from any point P, x, y, z, and the distance to the any of the planes, say here YZ plane, so the perpendicular distance, or the distance from the point upon the plane, is given by mod of x. So here also we can say the distance from the point P whose x coordinate is -3. So to the yz plane can be taken as the mod of -3. So therefore we can write the distance of point P -3, 4, 5 from yz plane is given by mod of -3, which is equal to 3 units. If the distance from point to the xy plane is mod z, and if the distance from point to zx plane is mod y. So here mod x coordinate we have to apply the mod because distance cannot be negative, so 3 units, which is our option 4.